Welcome to Tricentis API Simulation, a service virtualization solution for Tricentis test automation. Today, we're going to be going through 3 steps. We're going to do an introduction into simulation, what it is, what are its use cases, how it's used. Then, I'm going to show you how to install and set up your first simulation agent. Once that's set up, we're then going to go ahead and create our first simulation. Let's go ahead and get started with an overview of service virtualization and simulation. So in modern multi-tier applications, typically it's set up architecturally with a front end, some sort of middleware system, but then each system will have a series of backend components. Those could be APIs, they could be databases, partner systems. When it comes to running test automation, all of those components need to be working at the time that you're running your test case. If at that time those systems are unavailable, unstable, or lack the proper test data, it blocks you from running your automation. And this is the point of API simulation. The technology allows you to create simulated representations of those backend systems and then deploy them into your test environments to stabilize for test execution. But let me go ahead and give you a quick demonstration to put this into context. So I'm going to go ahead and take a look at the Tricentis test automation portal. The simulation components are located here, and in these it allows you to build simulation and then deploy it into test environments. Now for today's demonstration I have an application, this application, and what this allows me to do is to get an insurance quote for a user. Really, this could be any application that has backend dependencies. Spoiler alert, I've actually broken this application. There are some components in the backend that don't work today, and I'm going to show you what that looks like and how to fix the problem. In my particular use case, I need to go through a series of steps before I can get a quote for my insurance policy. But in order to get that quote, I need to fill out all the necessary information. This particular page is actually broken, and I'll show you what that means. If I go ahead and fill out some information for my user, and I hit enter, something was actually supposed to happen here. These fields were supposed to populate. Now I might not know that, and my test automation might not know that, but if I tried to proceed forward, it would be blocked and I couldn't do it. And the reason that this page didn't populate was because that API in the background is offline. Now, I may not see any of the logging information, and as a tester, it's difficult for me to debug what's going on, and that's where API simulation becomes important. In API simulation, we're broken into 2 components, simulations and simulators. Simulation hosts all of the virtual services that you've created in a library that allows you to deploy them at your leisure to the environment of your choice. What you're deploying to are the simulators. Simulators are just lightweight agents that are stood up that host the virtual services and provide the responses back to the system. The simulators are actually listening in the environment. So if I had come into my logs, I would have actually seen, oh, there's actually something wrong in the backend system. I can't connect to this getPerson API. I need simulation. And so as a user, what I would do based on this information is I would go into my library of simulations, I would choose the appropriate service, either by name or based on tags, and I could right-click and deploy that into my simulator. Here I have a simulator that's connected to that demo application. I'll go ahead and choose that and deploy. And what that's now done is taken the simulation and pushed it over to that container, which is now connected to the application. I've now stubbed out the API sitting behind this form. So if I were to reload this page and then do my use case again, I would see that data actually coming from my virtual service. Let's try it out. Okay. And this is great because it means now I'm not blocked and I can proceed forward. I can deploy the simulation as a part of my test automation strategy whenever I notice that there are broken APIs or bad endpoints. In the simulation, I can actually go and look at the simulation that's currently deployed and make changes to it real time. So if I were to look at this service, and yes, it's code, we'll be talking about that in a later session, I could say, you know what? instead of providing this street address, maybe I'll give some longer field data or maybe some special characters. Essentially, I'm changing the service behind the scenes real time. And then I could come into my system and verify functionality on APIs that I don't even control and really prove out crazy use cases and corner behavior that wouldn't traditionally be available in that system. Here I see I might have a defect. This field doesn't actually let me know that the characters are too long. So in general, that's how API simulation works. Let me walk you through how to set up your first simulation agent. And so to do that, I'm going to go ahead and open a new portal. This one is brand new, and actually I have no simulators connected in this portal. I can download a simulation agent either by clicking on this button or by clicking on the Downloads button, and then I simply choose which operating system I want for the simulation agent. I'm on Windows today, so I'm going to go ahead and download the Windows agent. It's small, so it shouldn't take very long to download. And once it's complete, we can go ahead and look in our file system and take a look at the file. It should just show up here in 1 second. Here we go. You want to move this to the location that you want the simulator to live. It doesn't really matter. You can move it at a later time easily. But for now, I'm going to go ahead and extract this to my file system. And this is my simulator. It's comprised of the actual simulation agent, and then a workspace to hold my simulations files, and an app settings file to connect to the portal. Simply double click your agent, and it will start up a dialog that allows you to start it directly. But today what I want to do is I want to connect it to the portal. So I'll go ahead and say connect to portal. It'll ask you for your tenant. The tenant is the first part of your URL. In this case, my tenant's called Chris. I'll go ahead and provide it that name. Space is optional. And then you want to go ahead and provide it your client secret. On earlier videos, you saw that we could get the client secret from the documentation here under Get Client Secret. And essentially you go into the Swagger, authorize yourself, and you'll get a key. I've actually gone through that process and I have my key just over here. I'm going to copy it. I'm kind of keeping it out of view for now. And then I'll go back to my system, paste in my key, hit enter, and the simulator starts. You could run this exactly the same on Linux and Mac. And if you're interested in the Docker container, it's in the Linux installation. Okay, I'm good to go. Let's go back to my simulator UI now. And I'll see that my new simulator is up and registered. But if I were to dive into this, I don't have any simulation files. So that takes us to the final part of the demonstration, which is, let's create our first simulation file. So a simulation can be anything. You're literally copying and mocking systems. To make this easy, we've actually created a sample simulation that you can create here in your library. So we'll go ahead and say, create simulation file. And this is what a basic simulation file looks like. It's saying right now that I'm listening on HTTP, and that if a request comes in, I'm going to respond with, it works. I'm going to give this a little bit more information so I can make it personalized to myself. I'm going to call this my Hello World service. Now, I'm going to tell it, actually, I'd like you to listen on a specific port. And the tool will provide you with all of the necessary fields. And once you have some information about those fields, why don't we listen on 7777 today? Then I'm going to tell it, instead of the response, it works, I'm going to say, hello world. And there's a lot more to this, but I'll show you in the documentation how all of this comes together. All right, I've created a service in my library. I'm now going to go ahead and deploy that to my simulator that I just stood up. And now that I have the virtual service, I could go and look at it by going over to that simulator and seeing the service, but it's the same as the version that I just deployed. And what that means now is that if I were to, say, hit a service on the endpoint where my service was deployed and give it that port 7777, it should respond back to me with hello world. And so that's basically it. From this point, you can now proceed forward, reading through the documentation, taking a look at the different elements that are available, set up simulations, and stabilize those test environments. Good luck and happy testing.